Hey guys, the last completing the square video. So in this one, we have situations where we have a number in front. Now notice that there's a number in front here, but there's not a number in front here. So we might be tempted to say, okay, well, if I take the square root of this, I get 2x, and the square root of this is 7. And 2 times 7 is 14, times 2 is 28, so that works out. So this is actually true. That's actually true, but it's not what they're looking for because there's a 1 here, not a 2. So we need to force this to look like this. So how are we going to do that? Well, we are going to first break it up and ignore the 49 like we did in the last video. So even though it is a perfect square and it does work, it's not going to work for our purposes because I can't divide it by 4, right? 49 is not divisible by 4. So I'm going to say 4x squared plus 28x, leave a space, plus 49. Because 49 is not going to work for what I need. Then I'm going to factor a 4 out of these two. Just these two. So I get 4x squared plus 7x. And then I'm going to leave a space, plus 49. Because I need something to complete my perfect square trinomial here. Unfortunately, 7 divided by 2 is not a nice number, but it's what we've got to work with. So if I divide this by 2, so my 4 is just going to come along for the ride for now. And then I'm going to have x plus 7 over 2. I'm allowed to do that. It still works. It's not pretty, but it still works. So here I'm going to have 7 over 2 squared. So I'm going to have 49 over 4, right? 7 squared over 2 squared, 49 over 4, which is not pretty. So we could have just factored out the 4 to begin with. We could have just said, okay, 49 over 4. But I wanted you to see why we could do that. Which is why we did it this way. So either way is fine. We could have not pushed the 49 to the side. We could have just factored 4 out to begin with. And then we would have gotten this minus 49 over 4. So we added 49 over 4. We need to subtract 49. Oh, no, we didn't. We added 49 over 4 times 4. So what we added was 49. So this is important. I mean, it's all important, but here we go. So if I have a number out in front here, I have to multiply this number by this number, and that's what I'm subtracting. So again, I could have done without all of this shenanigans, but I wanted you to be able to see it. So this times this is what I'm subtracting because I could distribute the 4, right? And then you would see that what I really added was 49, not 49 over 4. So this times this is what I really added. So that's what I have to subtract. So 49 and negative 49 cancel, and we end up with just this equals 0. And then I can divide both sides by 4. And then I would end up with 0 divided by 4 is just 0. The 4's cancel. So I end up with 7 over 2. and this is just still 0. So that was the longer way to do this. So I want to show you really quickly what the shorter way to do it would have been. You probably already know, but if I just left this as plus 49, factored 4 out of everything, x squared plus 7x plus 49 over 4. Then I still would have divided this by 2, gotten 7 over 2 here, said, okay, 7 over 2 is 7 over 2 squared is 49 over 4, so this is correct. And then I would have been done, and then I still would have said that equals 0 and divided by 4. So that's a longer way to do it. If this hadn't been correct, that would have caused some problems. So the way I did it the first way is a little bit more foolproof, I guess. But if you know that this is a perfect square trinomial, like if you know that this would have worked, then this will also work. But if you're not sure that this is a perfect square trinomial, or if this, especially if this isn't a perfect square trinomial, then you would need to leave the 49 off to the side, complete your square, and then multiply and add. So let's do another example. All right, so the first question we're going to ask ourselves is this a perfect square trinomial? It's not. This is not a perfect square. This is not a perfect square. Yeah. So what we're going to do is we are going to, again, we have to force this to not, to be a 1 here. So I need to factor out a 2. I'm going to ignore the 20 for now. So I'm going to have 2x squared plus 13x plus 20, right, out to the side. I'm going to factor out a 2. So I get x squared plus 13 over 2x, which is not fun, but there we go. Leave a space plus 20. And then I need to divide 13 over 2 by 2. So 13 over 2 divided by 2. Remember, that's 2 over 1. So I can multiply by the reciprocal. So I can multiply top and bottom by a half. These cancel, and I end up with 13 over 4. So that's what I'm going to have down here. X plus 13 over 4 squared. And then it's going to be plus something, but I don't know what yet. So 13 over 4 squared. 13 squared is 169. And 4 squared is 16. So that is 13 over 4 squared. And so since I added 13 over 4 squared, should be an addition sign right there, I need to subtract 169 over 16 times 2. Remember, I have this 2 out here, so I need to subtract this times this. So I need to subtract 169 times 2, 16. Just multiplied it by 2, right? I didn't actually do the multiplication because I'm going to simplify it. So I can say, okay, 2 goes in to 16 8 times. So what I really have here is 20 minus 169 over 8, which if I put that in a calculator, I get negative 1 1/8 or negative 9/8. Negative 9/8. So over here I have negative 9/8. So this, sorry, it's kind of hard to see, is my answer. If you're wondering how to do this by hand, you would get a common denominator. So 20 times 8 is 160 over 8. So 160 over 8 minus 169 over 8 would be the negative 9 over 8. All right. So what do I put here? Well, that's my 2. This is always going to match this. Unless it's a situation like last time where we can divide it out because we had it equaled 0. So we just divided by 4 in the last example. Otherwise, these are going to match. This is our 13 over 4. And this is just telling you what form it should be in. And this is our negative 9 over 8. So that is completing the square. And let's do one more of these. Yeah, let's do one more of these. This is not as complicated, but I'm going to do it anyway. So with this one, again, negative 20 is not correct for a perfect square trinomial. First hint is because it's negative. So this is bx squared minus x minus 20. And so if I divide this by 2, remember this is really negative 1 here. So in my next step, I'm going to have negative 1/2, right? If I divide negative 1 by 2, I'm going to have negative 1/2, and then we're going to square that. So negative 1/2 squared is positive 1 over 2 squared is 4. So positive 1/4. And then I have to also subtract 1/4. So this is my perfect square trinomial. And then I have to take care of this. So I have negative 20 minus 1/4. Negative 20, to get a common denominator, I would multiply that by 4. So that's negative 80 over 4 minus 1 over 4, which is negative 81 over 4. Not that this matters, but that's negative 9 over 2 squared. Just something that I noticed. Again, not really important. Notice the negative is outside of my parentheses. That is important. So negative 81 over 4 is what we have. I just thought the fact that they were both perfect squares was interesting. That's why I wrote it like this. It doesn't really matter. Yeah. So anyway, but they don't want it in this form. They want the squared thing equals something. So right now this equals 0. So we need to add the negative 81/4 to both sides. So we get x minus 1/2 squared equals 81 over 4. Remember, we're adding it to both sides, so the sign changes. So 81 over 4. Oops, this one. All right, so this is negative 1/2, and this is positive because we added it to the other side. 81 over 4. That, I think, is all the examples I'm going to do of this. Let me know if you have any questions, and I will see you in the next video.